So today what we're going to do is start factoring basic trinomials. But the first thing I want to do before we get into the actual trinomials is do a real quick review of how to find the GCF and factor out that GCF with leftovers so you can get back to your original problem. So let's say, for example, that I gave you the following. 20 ABC plus 15a squared c. So the first thing I want you to do is I want you to find the GCF of each of the terms. So numerically, if you look at the 20 and the 15, your GCF would be 5. Now start looking at your variables. Well, they have one A in common. They don't have any B's in common. They only have one B here, but not in the second term. And then they do have one C in common. Okay, so your GCF is actually 5AC. What I want you to remember, though, is when you're factoring completely on a problem like this, you then have to take and work backwards. Remember, we've been using the distributive property to take and find our answer. Now what we're doing is we've been given the answer, and we have to use the distributive property to figure out what the actual problem had been, what the multiplication problem had been. So, to get from 5 to 20, we know we have to multiply by 4. From A to A, well, that stays the same. I need a B, so I have to multiply the 4 by B. And then my C's stay the same. So if I multiply 5AC times 4B, I should get 20ABC. Now, on the other hand, with the 5AC out of the second term, to get from 5 to 15, I got to multiply by 3. To get from A to A squared, I need to multiply by A. And then to get from C to C, well, I just multiply by 1, so I really don't need to multiply by anything in this one. Okay? These, remember, are my leftovers. And I'm going to take my leftovers and I'm going to use them to go inside of the parentheses. Okay? So my leftovers go inside of the parentheses. My GCF goes on the outside. So 5AC is my GCF on the outside. And then on the inside, I write my 4B and my 3A. And because it's an addition problem, I bring the addition sign down in between. So my final answer is 5AC times 4B plus 3A. And I know that this is the right answer because if I go through and I redistribute to check myself, 5AC times 4B, well, 5 times 4 is 20, A times B times C, that matches. 5 times 3 is 15, A times A is A squared times C. So that's how I know I have the right answer. To check and make sure that we're on the right track, what we're going to do is we're going to just do a couple of problems just to make sure we know what we're doing. But this time your directions are going to be to factor completely. Now, when it comes to factoring, and especially with greatest common factor, you're not going to be told specifically to find the greatest common factor. Okay, this is going to be something that is assumed that you're going to know how to do. So the directions when it comes to this entire unit, it's always going to be factoring completely. There are 5 different types of factoring that we're going to learn. Okay, and this GCF is just the first one. The next part of the lesson is method number 2. Okay, so 20x squared minus 24xy squared. So the first thing I need to do is I need to find my GCF. Okay, and numerically between the 20 and the 24, your greatest common factor is 4. Okay, I have one x in common, and I don't have any y's in common. So 4x is actually my GCF. So to get from 4x to 20x squared, I would multiply by 5x. And to get from 4x to 24xy squared, I would multiply by 6y squared. So when I'm creating my answer, my 4x goes on the outside of the parentheses, and then my 5x and my 6y squared go on the inside, and because it's subtraction, I drop the subtraction sign in. Remember, however many terms I start with in the original problem, in this case I started with 2 terms, that's how many terms I need to have in my parentheses within my final answer. Well, what if I gave you this one? What if I said 7a to the 4th plus 7a squared? Well, if I GCF numerically, what's in common between 7 and 7? Well, itself. So numerically, my GCF is 7, and then I have 4 A's and I have 2 A's. So really that means I'm canceling 2 A's out. So they share an A squared. So my GCF is 7A squared. Now to get from 7A squared to 7A to the 4th, well, 7 times 1 gives me 7, and A squared times A squared gives me 7A to the 4th. In this problem, to get from 7A squared to 7A squared, all I have to do is multiply it by 1. This is super important that you're recognizing that you're multiplying it by 1, because when you go back and you start to check yourself to make sure that your problem is actually matching up, or your answer is matching up to your original problem, if you don't have that 1 there, then you're just going to end up with a single monomial term. You'd end up with 7a to the 4th, and that's not what you started with. So you have to have that plus 1 there, so that way you at least get back this 7a squared that you would get there. Okay? So in this next section, we are actually going to start looking at the lesson for today, which is factoring general trinomials. Okay? So factoring general trinomials. The first thing I want you to know, and I want you to realize, is that all trinomials are in the form ax squared plus bx plus c. This is the format of every trinomial we've ever worked with when it comes to multiplication or just trinomials in general. You've always had a variable that's been squared, then the variable again, but just as a power of 1, and then a constant. So you have an a and a b, which are coefficients, so those are the plain numbers, and c again, which is the constant, so that's the number without the variable. So, like I said before, whenever it comes to directions within this unit, your directions are always going to be to factor completely. There are 2 different lessons when it comes to trinomials and factoring trinomials. Today's lesson, what we're doing is we're looking at trinomials when you have a leading coefficient of 1. Okay? So that means when that a equals 1. Okay? You are going to be doing problems within the next couple of classes where your a is going to be greater than 1. So today what we're doing is just the more basic of the formats. Okay? So your first problem that we're going to look at is x squared plus 6x plus 8. And this is in the format of ax squared plus bx plus c. Now when you're looking at this, you should notice that your leading coefficient here is 1. It's an invisible 1. So if you want to write the 1 here, you can. Okay. Your b in this case is 6. So your coefficient for the second term is 6. Your constant is 8. All right. Factoring this kind of trinomial, what I'm trying to do is I'm trying to figure out what two things am I going to multiply together. So what two sets of parentheses will I multiply together in order to get this as my final answer? All right, so there are steps when it comes to factoring basic trinomials. Okay. The first step that you're going to do is you're going to create a t-chart. Okay. And when I'm talking about a t-chart, what I'm looking for is I'm looking for on one side or on the left side, I'm looking for the factors of A times C. Okay, so going back to my problem, I'm going to figure out this idea right here. So this A times C, which is the same as 1 times 8. Okay, so my t-chart is going to look something along the lines of this. So basic t. And on this side, I'm going to put down the factors of 8, because 1 times 8 is 8. Okay? Step 2, what I'm going to do is I'm going to find the sum of the factors that add up to b. So whatever number is that second term, I'm going to take and I'm going to figure out what numbers I can multiply to get to 8 that will, when I add it, will add them up and become 6. So for example, I'm trying to think of the factors of 8. So the factors of 8, let's see, 1 and 8, 2 and 4. Okay, so if I'm thinking now of the factors of 8 that sum up to 6, well, I would think to myself, okay, 1 plus 8, which is 9, and 2 plus 4, which is 6. So of these two, the 2 plus 4 sums up to that center term. It matches the 6. Okay? What I've got right here are two major parts of my answer. Now, one thing though that you need to remember is that whenever we created trinomials, we always took and we multiplied two binomials in order to get the trinomial as the answer. Well, I've got two parts right here of the binomial. I know it's going to be a positive 2 because this is a positive 2. And I know it's going to be a positive 4 because 2 times 4 gave me 8. Now what I need to do is I need to figure out, well, what do I do to break out this x squared? So what times what gives me x squared? And that's x times x. Okay? Because, again, remember, a binomial times a binomial gives me a trinomial. Okay? So now I got to see if I'm right. Okay? So in step 3, what I did was I rewrote my problem using my factors. Okay? So when I rewrote it using my factors, that's where I got that x plus 2 and x plus 4 from. And then finally, what I'm going to do is I need to check my work. Okay? And I'm either going to FOIL or box. I cannot stress to you enough how absolutely important this last step is. It does not take you long, but it will make the difference between whether or not your problem is right or whether your problem is wrong. As we get into larger trinomials, meaning when you have a leading coefficient that is larger than 1, it is super important to go back in and check your work, because I guarantee you it's going to happen to you and you're going to end up getting something wrong. Okay, so just for space purposes, I'm going to box. And remember, if you're a foiler, you just look at my inside stuff of my inside of my box and see if we match. So x and 2, x and 4, x times x is x squared, 4 times x is 4x, 2 times x is 2x, and 2 times 4 is 8. Okay, when I combine my like terms, I see I got a 2x and a 4x. Well, that makes a 6x. And there it is, x squared, 6x, and 8. So that's how I know I got my answer right. Okay, so my final answer, my two binomials that I multiplied together, are x plus 2 and x plus 4. Okay. All right, so second problem, y squared minus 4y minus 45. Okay, so according to our rules, we need to set up our table and think of the factors of negative 45, because it's a, which in this case is 1, times c, which is negative 45, and they have to sum to negative 4, or my b term. Okay, so if I'm going through and I'm doing factors of 45, well, it has to be negative. Negative 1 and 45, negative 3 and 15, negative 5 and 9. Okay, now, but one of the things you need to realize is that when you start adding these together, this is going to give you a positive 44. This is going to give you a positive 12. This is going to give you a positive 4. Well, we want our answer to become a negative 4. So the placement of the negative does make a difference. So I could do negative 45 and 1, negative 15 and 3, and negative 9 and positive 5. Okay? Because now what's going to end up happening, as you can see, it's now taken and making my answers a completely different value. It's making it its opposite. But I want it to be the sum of negative 45, the factors of negative 45 that add up to negative 4. Well, that's right here. So when I go in and I start plugging this out, my binomials, I know I need a negative 5. So here, a negative 9. So here's my negative 9. I know I need a positive 5. There's my positive 5. Now all I have to do is just take that y square and break it out. Well, y times y is my y squared. So take the time to do your check and FOIL or box, whichever one you want. Box for me because of the space. And you've got y and negative 9, y and positive 5. So this becomes a y square. Here's the 5y. Here's the negative 9y and the negative 45. These two are like terms. Negative 9 and positive 5. Well, 5 minus 9 is negative 4. And I want it to be negative 4. So therefore, this is my answer. Okay. Another kind of problem you're going to see is going to look a little bit like this. Y squared plus 13y minus 48. Now, when you're creating your t-chart, sometimes what happens is that you get pretty lucky and you figure out your factors fairly early. Sometimes it takes a while. And that's perfectly okay. All right? Sometimes you're just going to have to keep going. So now what I'm looking for is the factors of negative 48, because 1 times negative 48 is negative 48. That sum to 13. All right? So negative 48, well, let's see, that's negative 12 and 4. Negative 4 and 12, because remember, of that placement, it's going to make a difference. Negative 6 and 8. Negative 8 and 6. Let's go easy. Negative 1 and 48. Negative 48 and 1. I'm going to go ahead and start adding together just to see if I've got anything. Excuse me. So this becomes a negative 8. That becomes the positive 8 because it's just the opposite. That's the positive 2 and the negative 2. That's a 47 and a negative 47. It's got to keep going because I need it to sum up to 13. So let's see. 24. So negative 24 and 2. Negative 2 and 24. Well, that gives me a negative 22, and that gives me a positive 22. So 48. So the only other factors I haven't tried yet are negative 6 and 8 and negative 8 and 6. So negative 6 and 8 is positive 2. And, oh wait, I've already tried those. Just kidding. So, let's see. What else haven't I tried? Oh, well, here's one. How about negative 16 and 3 and negative 3 and 16? So let's see, negative 16 and 3 is negative 13, and negative 3 and 16 is positive 13. Well, there it is. That's what I'm looking for right here. I'm looking for that negative 3 and positive 16. So I should have y minus 3 and y plus 16. Okay, do your real quick check. Just to make sure. So y and negative 3, y and positive 16, that's y squared, that's 16y, that's negative 3y, and let's see, that's 848 negative. So let's see, these two are the same. 16 minus 3 is 13, and the negative 48, so you got your answer right. Okay. Finally, the last kind of problem I could see. Okay, something like this: a squared minus a plus 6. A squared minus a plus 6. Okay, so I'm going to start my t-chart. I need to find the factors of 6 that sum to negative 1. So let's see, the factors of 6. So that's 6 and 1. They're both positive. So, but it's going to sum up to a negative. So those two are positive, but I also need to remember that two negatives can make a positive. Okay, even if I flip the order around and write negative 6 and negative 1, it's still the same thing, so I don't need to rewrite that again. 2 times 3 and negative 2 and negative 3. So let's see, that makes 7. That's negative 7. That's 5. And that's negative 5. So, whenever this situation comes up, it's not a does not exist. It's not an I don't know answer. You will not have an IDK on your SOL test. But whenever you have a problem that looks like this, the answer can be written out in a single word. Okay? The answer to this problem, because it cannot be factored, means that it is prime. Now, to be prime doesn't mean, what you're thinking. You're thinking that prime means one in itself, and it does. You're exactly right. However, in this case, the word prime is saying there are no two factors that when we multiply them together add up and make the two binomials that we need. So therefore, whenever you have a problem that cannot be factored, just like you see here, then the answer is prime.